So now we're all being recorded. Okay, so topographic maps. Let's talk about this. So I'm going to go through these slides. I'm going to skip the first few because they talk about maps in general. We kind of already did that yesterday. So I'm just going to skip to this slide. So lots of definitions here. First one is topography. So topography is our next, possibly last unit in this class. So we just did stratigraphy. Now we're moving on to topography. That's another graphy word. I mean, it's basically the study of what the land looks like. You know, is there a hill here? Is there a valley here? Is it all flat? Topography is the study of what the land looks like. Elevation is the height above sea level. So you're going to hear me say the word a lot, elevation. That means the height above sea level. Or you can just think height. Elevation is the same as height. High elevation means high, low elevation is low. Yes, go ahead. Yeah, so if you guys, I just left it there in case you guys want to take notes there. You don't have to, but some people find that handy. You might hear me say north, south, east, west a lot. So, or I might just say up and down. But if I do say north, west, east and south, excuse me. Just use that diagram to know which way is which on these maps. So what is a topographic map? So when we talk about topography in this class, we're almost always going to deal with maps. So a topographic map is a two-dimensional way of showing a three-dimensional image on the Earth's elevations. So for example, in this diagram, they have a hill at the bottom, or actually two hills actually. So that bottom image is the side view, like this is what it would look like from the ground. The top image is kind of what it would look like from the air, but not really, because we don't have any light, we don't have any shadows. It's kind of a simplified version of what you would see from above. So how exactly do these maps work? So I'm going to show you guys a simple example. So here's a topographic map. So you notice that mine is marked off with numbers. So these could be like feet. I could have like 100 feet, 200 feet. So what this is showing, like if I just had like maybe, here's me, I'm coming along, I'm a hiker. And what this means that every time I cross one of these lines, I go up 100 feet. Now, so if every time I cross the line, my elevation raises by 100 feet. Now, are these lines spaced evenly? Like, let's say if I was going to climb up a hill and I was going to go this path. You know, are those lines spaced apart evenly? No, sometimes, but for the most part, no. Notice that here, between 100 and 200, you remember, so this whole circle or this whole line is 100 feet. This whole line here is 200 feet. Between 100 and 200, and then compare that to 200 and 300, which part of the path would have a steeper slope or would have a quicker ascent? So I'm just talking about between these two right here. So 100, 200, and 200, 300. Which path would I have a higher elevation more quickly? Yeah, so here I'm between 100 and 200, and I would rise quicker because there's shorter paths. So this is a steep slope right here. That's steep. And that's a very gentle slope. So the closer the lines are together, the steeper the slope of this hill. The farther apart, the more gentle the hill would be. So it might not be obvious to you guys just by looking at that, like, oh, here's a steep slope, here's a gentle slope. It's okay. This lab that we're going to do is going to try to help you visualize that. But my point is that if this was a map of a hill that I wanted to climb, maybe there wouldn't be any paths on this hill, or maybe I'm drilling for oil and I want to find the best part to drill. Lots of people use these maps for those kinds of things. Hikers use them just to know where the safest place to hike is, or maybe a good place to camp. If you're drilling for anything and there's no development, these maps are really good to show you the area. So let me go back. Let me show you some a little more complicated example. Remember how to get back to it. There we go. So if you, on the sheet I gave you guys, this that gives you a picture of Mount St. Helens. Does anybody know where Mount St. Helens is? This was a big event probably in my parents' time. So this is Mount St. Helens was in Washington State. In 1980, Mount St. Helens blew up. It's an active volcano. So it's top blue. So this is before the eruption, and here's after the eruption. So it's a big difference. And so the ash from Mount St. Helens went all the way to Chicago. It was so dark in Chicago from Washington State. So sorry, Mount St. Helens in Washington State, but the plumes of ash traveled all the way to Illinois. I'm not sure about Missouri. It caused the streetlights to go on in the middle of the day. That's how dark it was. So this was a big eruption. I think only 1 or 2 people died. But the point is, here's what the mountain looks like beforehand. And they kind of show you a topographic map. Remember, I said that the closer the lines are together, the steeper the hill. Well, in the middle of this diagram, in the bottom, you see there's lots of lines that are close together. After the, oops. I'm sorry, this is before eruption. And here's after the eruption. Say what? Mm-hmm. So one term that I'll be using is contour lines. So these lines that I was showing you guys, whoops. These lines that I was showing you guys, these are called contour lines. So each contour line is showing you a specific elevation. So for example, this first one is 100 feet. The second line is 200 feet. And so this line all the way across will always and forever be 100 feet. And usually when you cross, if you were like crossing the line with your pencil or finger or whatever, it would mean you're going up by so many feet. This one uses a difference of 100 feet, but some diagrams use 300 or 1,000. Just depends on what the terrain is. Let's see here. Just want to make sure there's anything, okay. Yes, and this is something we went over too. This is just something good to remember, that contour lines that are widely spaced mean there's a gentle slope. Shut up. Lines that are close together indicate a steep slope. So I'm going to save the rest of the slideshow for another time. Probably not. What I want to go ahead and get started on showing you guys what your lab is going to look like. What we're going to do with these maps, and we're basically going to make this map come alive. So we're going to use, it's going to sound kind of funny, but we're going to use salad lids to make a 3-dimensional hologram from these maps.